Hello, I'm Professor Richard Lucas from Aberystwyth University, and I'll be talking about change, impacts and pressures and evidence needs. I'd like to thank a whole range of people who have contributed to this in the UK, in Australia and through Europe as well, through various projects, and their help has really been appreciated for the project. So first of all, a role for structured land cover classifications. A number of approaches to land cover are available. And one that we particularly like, and which is globally applicable, is the FAO, Food and Agricultural Organization, Land Cover Classification System. It's a very structured classification in the sense that it has what we call overarching environmental descriptors. And there's 8 of those. They're cultivated terrestrial vegetation, natural, semi-natural terrestrial vegetation, and the aquatic equivalents of that. And then artificial surface, naturally bare surface, artificial water, and natural water. And we call those level 3. And then there's essential environmental descriptors. And as you see, for natural, semi-natural terrestrial vegetation, that relevant to forests is height, leaf type, life form and cover, leaf phenology and stratification. And then you can further describe those land covers by considering abiotic, biotic and human influenced descriptors as such as above ground biomass. So these descriptors can feed directly into the land cover classification, and a lot of those can be retrieved from satellite imagery. So the overarching and also the essential environmental descriptors, and we call them essential because they're used for the construction of the FAO land cover classification system, include things like woody herbaceous. So we can use, for example, in Australia, you've got Australian National University's woody cover fraction. Annual photosynthetic vegetation fraction, again, that gives you a cover estimate or a relative measure there. Bare surface, water hydro period, water seasonality of vegetation, and so on. So each of these has defined units or categories. So woody is 1, herbaceous is 2, it always is. And all they have units such as percent or meters or above ground biomass in tons per hectare is one we're going to talk about next. So these are the ones that you can provide further descriptions, and this is an example for the Gumbaru Kundruk Perikuta forest between Victoria and New South Wales in Australia. And here we have, again, a range of additional descriptors which describe the land covers. So we've got natural terrestrial vegetation, for example, and you can describe the amount of green and brown material, the height from, say, Iceland or Jedi, tasseled cat wetness, woody fraction, above ground biomass, water hydro period, and dominant plant species. So again, above ground biomass comes from CCI biomass. And these are essential environmental descriptors, some of those, and they are, as you say, canopy cover is used for constructing the land cover classes, but also they're additional in the fact that you actually can have the continuous variables in there. So canopy cover is continuous as well as categorical. So, and again, in a sense, it's sort of essential and additional. The additional ones, you say, are things like plant species. So they can be brought in, and the result then is we combine them according to the literally through the structured classification, and you come up with very comprehensive classifications. So, for example, this is Australia. You can see how we've selected certain categories in there, and we've got the natural terrestrial vegetation, woody, closed, and greater than 65% cover, for example, and then you can then further attribute that with things like biomass and so on. Now, what you can then do is then combine those, obviously looking over time and see what's happening. So here we have mangroves in the north of Australia, and you can sort of then see that these are the classifications, but each of those tells you about the mangrove extent. You've got information on the cover of the mangroves, the water hydro period in this case, and you can add in more information like biomass, water turbidity, or a whole range of different parameters into there. What's really exciting about this is this has gone through the Australian data cube, through Digital Earth Australia and through Geoscience Australia, and we've applied it nationally at 25-meter resolution using the Landsat archive. And so what you can see here, and this is particularly interesting in terms of this one here, is you can actually see in the Grampians in Victoria, the fire, the bushfire coming in, and then it recovers. So you can see then, I'll leave that running for a little bit, you see the water, hydro period, then the fire, and then you get another fire then, but you get that recovery. And you can see loss of biomass through the bauxite mines in the north and actually creeping up through there in Western Australia as well. You can see that the progressive, clearing, but then there's also recovery as well. And there's urban expansion. So you start to get an idea of the changes that are happening. So through those 33 years of time series, you can then, obviously you've got the level 3 categories, which is the overarching environmental descriptors, and we can start to look at what we observe. So for example, the one on the left is actually the Opera House and Harbour Bridge in Sydney. And this little area here is where they've created a park of natural terrestrial vegetation because a native species in effect. And then you've lost the urban area, used to be a concrete dock. So that's a clear increase in the natural terrestrial vegetation, but then there's the opposite, because obviously actually that should be there is a decrease in other areas as well. But you've actually gained lost urban areas in that particular case. In the middle one, you've got the natural aquatic vegetation extent increase and decrease. You see there's primarily a decrease there because of the mangrove dieback, which happened in 2015 and 2016. And that's actually, these two cases are on the off diagonal. So what you do is you create a transition matrix, which provides effectively the first line of evidence for change. So the first two, basically, it goes from a change from an artificial surface through to natural terrestrial vegetation. That's 5 to 2, for example. And in the other case, you get you actually get naturally bare, a natural aquatic vegetation, and that then goes to a naturally bare surface. It could go to a water surface, but it's basically the extent as being lost of mangroves there. But the interesting bit is the on diagonals, because they stay the same. So you get a natural aquatic, in this particular case, you've got natural aquatic vegetation. And in the mangrove area in Hinchinbrook Island, you've got a decrease in the photosynthetic activity, and there's a change in biomass, for example, canopy cover and so on. That's because of a cyclone that came through, Cyclone Yassi. And so you can now see that actually on that on diagonal, the land cover, the broad classes, the overarching ones stay the same, but there's differences within those. And then you can start to look at biomass, height, cover, and all these different factors as well. So there's different approaches through that transition matrix, and that would obviously run through the data cube. Now, the interesting thing is, because you've got lots of things happening there, so what we thought we could do is actually then try and combine this to provide a much more evidence-based approach to looking at change. So what we take is the drivers, pressures, states, impacts, and response framework, which is a policy framework. And we link particularly the pressures and the states and the impacts. So the states are the environmental descriptors that we've been talking about. So we can use the states to make up the land cover maps. And the impacts are the changes effectively in state. They're the consequence of state changes. So we can look at those impacts and list them and look at the changes in states and the evidence for the different impacts. But you might get the same impact or different impacts. And so the pressures are different. So you can use other data sets from remote sensing and so on to actually do the pressures as well. And then you can start to bring that into land cover change and monitoring. So here's a better explanation, I hope, for that. So there's the drivers, pressures, states, impacts, and response at the top. The drivers are climate and economy primarily, and then the pressures are abiotic, biotic, and human influenced. The states will be canopy cover, canopy height, biomass, for example, or changes in those. And you can look at that, you look at those, obviously you might get something like in Hinchinbrook Island with Cyclone Yassi, you get a change, a loss of canopy cover, some loss of height, some loss of biomass. The dominant species might stay the same. You actually see, well, that's vegetation damage. And there's no other cases there. We've got vegetation dieback, vegetation reduction. The evidence builds up through those. So what you then do is then start to say, well, what am I going to do about it? So that's the response in there. But what the nice thing about this is that you might have this response. We want to say what caused it in the first place. You have this connection between the impacts and the pressures. So a dieback, and I'll show you in the next slide, might be due to an abiotic, a biotic, or human influence pressures. So what we then do is take other evidence to look at those pressures as well. And that all connects through to the FAO LCCS. Now, in terms of satellites for the impacts, we sort of look at things like, Landsat, Sentinels, JEDI. We could look at the ALOS data sets and so on. And that's really providing the evidence of the environmental descriptors. And you can use whatever you want for that one. And you can choose the best algorithm. And that's where things like harmonization activity, you say, what's the best, what's the most suitable for biomass and the uncertainty associated with that. Some impacts and pressures, or some pressures, can be taken from, say, time series of Landsat data. So, for example, water hydro period or fire frequency is basically a pressure, and that can then be taken from there and can tell you then why something has changed. For example, it could be long-term degradation of agricultural land, for example. And then the pressures came from a whole different series of sectors, like motors give you maybe fire. You can get moisture content, or get sea level as well. And that's where links to programs such as that deal with those are quite useful. So that whole framework then allows you to build up, first of all, impacts, pressures, and start to look for evidence and then try to map them. So here's an example. We've actually defined now 250 approximately globally relevant combinations. It's an interesting review. It really told us a lot, but actually a lot of them are quite common around the world. And because we define them using these descriptors with common units and categories, we can map them pretty consistently over time and through space. So here's an example of dieback. So there's one due to storms. So we've got the impact as dieback, storms as the pressure. Then we've got pathogens as the pressure, sea level drops the pressure, and bushfires the pressure. You see that different satellites, let's take some that will define the dieback, and others will define the pressure that go with it. So you can map those as well. And that's the case in Australia, and then Wales in the UK as well. So evidence requirements are different for impacts and pressures. The source of information vary. Time is also included in the evidence base. So we have a way of looking at describing the time varying manifestation of these impacts. And change can be negative or positive. So you actually can have positive pressure, which might be a restoration, for example, of the ecosystems as positive pressure. So it's an interesting process, but it's actually one that's globally applicable. So here's an example which Darren talked about yesterday, looking at forest logging or clear cutting in Wales. We've got the land cover information with all descriptors coming through as in Australia. And we use that information, including the biomass, to sort of try and work out then the evidence for clear cuts in there. And so as you build up your evidence, you can start to differentiate why the clear cuts have occurred, and you bring in pressures. For example, it might be due to pathogens, which you can get from citizen science data or so on. So those impacts pressures come from different sources, but their combination is quite interesting. So the evidence for pressures then, programs like the CCI, there's loads of programs doing this all around the world, and they don't have to be global, they can be local as well, but you can get an idea of the sort of things that can be used to identify the pressures. So it could be fire, for example, burnt area. It could be changes in sea ice concentration, which then lead to change in sea level, and so on. So you've got a whole range of pressures already quantified, and there's more you put together. So, it's sort of selected choice which ones you want to use and how you define your impacts as well. But the change taxonomy helps with that. So in summary, structured land cover taxonomy, such as the FAO-LCCS, provide a base for using environmental descriptors for land cover classification. The use of environmental descriptors with defined units or categories, including above ground biomass and height, percent, and so on, for canopy cover, for example, allows scalability in space and time. Change can be detected and described based on evidence obtained through time series comparison of environmental descriptors, and the land cover maps constructed from these. Biomass is one such descriptor. We've developed this new globally relevant change taxonomy, which integrates the concepts and terms of the drivers, pressure, states, impacts, and response framework, which is a political framework and widely used. We've got 248, we might go up to 250 or more. Again, people might identify more also. So we put these initial lists there. It's pretty global, it's pretty comprehensive, and they've been identified, and each term is described in the glossary. And the evidence for impacts and pressures can be obtained from Earth observation data, but other sources I mentioned, and they can be used to support mapping and monitoring of change. And we sort of indicated what might be used, but it's also up to the person to decide. And there's a forthcoming paper in Global Change Biology, which will explain the whole process and will provide the glossary and the evidence as well. And so we look forward to that being published, and we hope that's really helpful for you as well. So I'd like to thank you for your effort, for attending, and thank you very much for listening.